Let's bring in Francisco Diego. He is a lecturer of physics and astronomy over at University College. He joins us now from London. Francisco, I know you're watching these live pictures. Andy, just a moment ago, said there was a moment of about a window of 7-8 minutes where there was no communications between the capsule and mission command. I'm wondering if you could sort of talk to us. I know this has been a safe landing, but in terms of the dangers that are involved in space travel, although it's become common, it is still perhaps a risky operation. From the undocking moment to maneuvering or making orbit-lowering maneuvers and re-entering Earth's atmosphere, talk to us about how what some of the experiences the astronauts are going through.
Well, yes, it's the most critical part of the mission, really. Well, the launch itself and then the orbiting and coming down at enormous speed through the atmosphere before they slow down enough to deploy the parachutes. That we just saw amazing images reported from the coast in Florida. What happens is that the orbital speed is 25,000 kilometers per hour. Is enormous speed. So they have to slow down, decouple from the space station, and then slow down, lower the orbit until it's entering the atmosphere at an enormous speed. We are talking kilometers per second. I mean, it's really, really fast. And at that speed, there is a lot of generated by the friction with the top layers of the atmosphere, and this is why the bottom of the capsule that we don't see here, because it's under the water in this view. This view is a shield that protects against that enormous temperature, and this is what allows the spacecraft to survive. Now, here, because of the heat, the atmosphere around the capsule becomes what we call ionized. That means that it becomes a shield against radio transmissions. It's completely reflecting all the transmissions. So while that cloud of plasma is surrounding the capsule because of this enormous speed, then we have these several minutes of silence, the radio silence that we cannot communicate because of this shield that is in a way created by the enormous speed, until it slows down enormously and then finally goes to the denser part of the atmosphere, much lower speed, and then we have the communication again once this plasma disappears.
So it's because of the ionization of this plasma that there is this communications blackout window, which could last several minutes. I want to ask you about some of the extreme conditions that the capsule has to endure while it is re-entering Earth's atmosphere. Andy Roesgen, reporting for us from Florida, said that the temperatures could reach as high as 1,700 degrees. This is enough to melt most elements on Earth. So this has got to be some sort of special material that is on the shield of the capsule to protect itself as it passes through this critical phase.
Exactly. This is the thing. It's a special ceramic, and we sadly we remember the Colombia disaster when this shield failed because it has been damaged during the. It has been damaged by blocks of ice, apparently, that detached from the rocket, and then damaged this shield, and they didn't know the Colombia was entering the atmosphere, and then the shield failed, and we lost the astronauts there, and that was a major disaster. But yes, it's a very special material that it's a ceramic material that can withstand the temperatures that no other metal can survive, as you said.
Francisco, I want to talk to you about sort of where we are in this new age of in space research and discovery. I mean, obviously, NASA led this for the better part of a half century from the 1950s, and then we saw companies like SpaceX and Virgin Galactic and Virgin Blue come out. But now we're seeing companies like Axiom, which this mission is led by. I mean, I'm assuming that if it wasn't for the cooperation between the European Space Program and Axiom, we wouldn't have seen astronauts from Türkiye, from Sweden, from Italy go up into space at this ease.
Yes, indeed. This is actually making easier to launch more astronauts, and then with the and I sincerely hope that Russia returns eventually to the space communication, because remember that the space station is it has a Russian module as well, which is crucial for the survival of the space station. But certainly, yes, we have had an enormous amount of diversity. I mean, this makes honor to the international part, what is the International Space Station, that we have astronauts from so many countries already. And I'm very happy for the Turkish astronaut as well, that Turkey is now entering the club of the astronauts with the first flight. We had the first flight, the Swedish, and then we have the Italian and the Spanish U.S. astronaut Miguel Lopez-alegria, who is a super veteran, retired veteran in his 60s, I think he is, and still flying.
Yeah.
Yes, it is fantastic to see all this diversity of possibilities, and certainly Axiom and SpaceX is making this possible, as you said.
Francisco, let me read you a post from Axiom Space on X. They're saying that we're building the world's first commercial space station, Axiom Station. It will host people, research, manufacturing, and leading development for numerous industries using techniques that are available only in microgravity. Obviously, this is going to be a huge plus for space travel and research, because this will be perhaps an alternative to the International Space Station, which is aging.
Yes, exactly. International Space Station will be in orbit for a few more years, but essentially, as you said, it's aging, and it is time to be replaced. Another International Space Station, or this private SpaceX space station, following up all the experiments and all the technology being developing in the International Space Station already, and taking it further for more industrial applications, and then learn more about the long terms of humans in low gravity, which is a major challenge. We are thinking about space missions that go beyond the moon. We need to really understand the behavior of the body in low gravity. And one thing that is still is a major problem for deep is the radiation, the cosmic radiation and the solar radiation, that it will be always there. Once we leave the low Earth orbit and we go away from the Van Allen belts, from the protection that we have from our own magnetic field on Earth, then that will be a major challenge. And I assume that in the future we will have the Gateway space station in orbit around the moon, and those experiments are going to be carried on there. But certainly, this space station from the SpaceX is this next step to take before we go to the Gateway around the moon.
Okay, Francisco, just hold on just 1 second. There's a lot more that I want to ask you, especially about sort of where the next stages of space travel are, whether it's the moon or the Mars. But these are live pictures from the North Atlantic, where we can see now the main recovery vessel that is making its way towards the splashdown site. This is actually the vessel where you can see sort of, if we can come back to the to this image, you can see a fairly largest platform on the back of this vessel. So once this vessel actually reaches the splashdown site, it will use some sort of winch to actually to lift the capsule off the surface of the water, and then lift it out of the water and then onto the platform. Francisco, I want to read you a statement from Axiom Space. They wrote that, and I'm quoting them, he said that data collected on the ground before and after the mission, as well as in flight, will impact the understanding of human physiology on Earth and on orbit, as well as advanced scientific understanding. It will harness opportunities for industrial advancements and develop technologies for humanity's progress. Talk to us about how some of the things as a result of the experiments conducted by these 4 astronauts in the last 17 days in the International Space Station will actually help astronauts in their quest to advance their limits in space, whether it is the Earth's only moon, the moon, and as well as other planets, essentially making a step closer in terms of humanity's goal to make us an interplanetary species, as well as helping us here, humans on Earth, live better lives.
Yes, exactly. All these experiments doing in the International Space Station for many years, more than 20 years actually, we have been performing all these experiments and measuring the performance of the human body and developing new medicines. Actually, you can grow molecules in absence of gravity. You can do a lot of experiments and create new medicals that can help humanity in the future. I'm not exactly informed about the particular experiments in this mission of the Action 3, but certainly is another contribution even further for the enormous amount of data and information and research that we need in order to be safer when we go to space.
It's a beautiful early morning for splashdown.
So all this research is crucial for the future of humanity in space. As you say, eventually we're going to go to the moon, and I hope we do that as in a more global way, not as individual nations or companies, but in a more global way in the name of humanity. Mission did with these very famous plaques. They said that we came in here in peace in the name of humankind.
Mm-hmm.
So hopefully we will point. But certainly all these steps are crucial for this future exploration of space.
Francisco, tell me this. I was taking a closer look at some of the experiments that was conducted and led by Alper Gezeravci, the Turkish astronaut on this mission, on behalf of numerous Turkish universities and research institutions. And I saw a couple of experiments where it centered around artificial intelligence. Is this sort of, when you look the last several years in terms of the missions that have been going up to the International Space Station, a new theme that's sort of being led in these experiments, or have we seen artificial intelligence-based experiments for quite some time now?
This is a new field that we have in the last few years, that artificial intelligence and these algorithms are being developed in every single aspect of human life. And we have that in the university. We have the ChatGPT, which is in a way is an advantage to have all this generation of text and all that, and disadvantage as well because it's quite dangerous. But certainly, artificial intelligence is being used in everything today, and it's an enormous field which is developing at an enormous speed. Certainly, the application of artificial intelligence in space exploration is extremely important because if everything goes well with artificial intelligence, we can have the data processed much quicker and make judgments, and especially in situations of emergency, when we have artificial intelligence taking control and sorting out things that human couldn't do that quickly and save a mission, for example. But yes, it is important to use these tools that we have today in a proper way.
Francisco, let's just talk to our viewers and explain to them what we're seeing. We have seen a member of the recovery team dismount one of the inflatable recovery boats, which has made it to the scene where this Dragon 9 capsule has splashed down. It seems that they are tying some sort of towing mechanism to the capsule. We can see this from a better angle, and that will likely be used to bring it closer to the recovery vessel, the main recovery vessel with the large platform in the back. Francisco, coming back to you, we're experiencing a time when there has been increased interest in the moon. Before it was just a space race between the American and Russian space programs in the 1950s, 60s, and 70s. But now we're seeing a renewed interest in the moon after many years of absence. We've seen countries like Japan, India, which has also conducted successful missions. What is the reason behind this renewed interest in the moon?
Well, yes, exactly. Now we are in a position with all these developments, thanks in a way to the International Space Station, that many other possibilities have been developed, and we have inside proper exploration of the moon. Certainly, once we have learn about a little bit more about the behavior of the human body in low Earth orbit, then we have now much more information to go to the moon, and we see the moon. Well, there are a couple of things here that are of concern in a way. One of them, of course, is the exploration of the moon to continue with and the United States in the last century were doing to recover samples from the moon and bringing them back and analyzing the rock samples that they brought. And from those rock samples, we learned, for example, about the origin of the moon, about the collision between the Earth and another planet. The solar system was very young, and the possibilities, of course, now that thanks to one of the India space missions that detected water in the south pole of the moon, and now we are in a condition to think about exploring the moon in a more efficient way. If we know that there is water, for example, there, then that simplifies a lot the logistics of survival on the moon. Certainly, South Pole of the moon. And now we have many countries. Now we have, as you said, India, we have China, we have Russia, and we have all these countries have landed successfully and recovering samples. China made a fantastic recovery sample from the bay of the Sinus Iridium, one of the areas of the moon that has one of the most recent volcanic eruptions there, and recovered those samples in Mongolia a couple of years back. So all these missions are for the science, the origin of the moon, the quality of the material of the moon, possibilities of life on the moon, because in the past there must have been life. There was water there. There must have been some evidence for some life. And the moon also has a lot of dust collected from the interplanetary system and from the galaxy as well, that has a lot of information about the history of the solar system. That's the science. But for the other side, we have the commercial activities, which is a bit of concern for myself when we are going to start exploring and exploiting the moon for minerals, and to use the moon as a mine, if you like, and then with the risk of destroying evidence for science evidence that we may have used otherwise. But certainly, yes, once we have this gateway orbiting around the moon and then landing on the moon and establishing moon colonies, if you like, lunar colonies, then we are in a situation where we are finally settling in a different body, and this will happen later on this century, where we will see, or whoever is alive at that point, we'll see the formation of these little villages on the moon. And mind you, there is a couple of risks here. One of them is meteorites, micrometeorites that are all and still there have been damage of micrometeorites in the space station, for example, that produce little holes. That is still a problem on the moon. And certainly is the radiation from the cosmic radiation and radiation from the sun. And so all these villages, as we see in science fiction films or science fiction, when you see on the surface of the moon, or you see all these settlements, it won't be on the surface of the moon. They have to be underground. They have to be well by soil, because the cosmic radiation will get through. And astronauts going with their spacesuits outside for investigations there, he has to be very careful to monitor the radiation, especially coming from the sun. The Apollo astronauts were very, very lucky. The Apollo astronauts very lucky that we didn't know much about the solar storms, but there was no major solar storms during the Apollo missions. That was a miracle, because otherwise the astronauts would have been in severe problem, because they were away from any protection from the Earth.
Francisco, with each passing minute, the Dragon 9 capsule is being towed closer to this main recovery vessel. A fantastic overhead shot, seeing the main recovery vessel as well as the smaller vessels, but the center of attention is on the top of that screen, that white dot you see here in the middle of your screen now, the capsule that has returned back to Earth after a successful splashdown in the North Atlantic Ocean. We are waiting for that to be sort of towed in closer. Francisco, I want to ask you, since we're talking about using the moon as sort of like a stepping stone in reaching further out to space. If you go back and listen to some of Elon Musk's talks, lectures around the world, he often points out that one of the most critical issues in achieving success as an interplanetary species is the fact that we can have reusable rockets in a very quick fashion. And I think that has really changed the whole picture here. SpaceX developing these types of rockets, and I believe the next launch is going to be in the next couple of weeks. Before, in the 60s, 70s, 80s, when you had these space shuttles, I think it was 6 in total, you had to wait months, perhaps even years in between missions. And that was a huge handicap in terms of how much you could do in a particular amount of time.
Yes, exactly. The fact of reusable rockets and reusable capsules, because this capsule, I understand, has flown before and it will fly again. So they need a bit of refurbishing. It brings the cost down and the turnaround time as well, as you mentioned. The space shuttle, if we remember, had the main fuel tank and the rockets in the space shuttle itself, and the two the solid booster rockets that were landing on the sea, and they were recovered and they were used again. But they were recyclable, if you like. But in this case, yes, this amazing venture of SpaceX of recovering rockets and landing them so beautifully on these platforms on the sea with enormous precision to be used again is fantastic. And it, as I said, it reduces the cost and reduces the turnaround time. So we will see the same rockets flying again in a few weeks' time. It's fantastic.
All right, Francisco, thank you very much for joining us here on this special coverage as we witnessed the successful return of this Axiom 3 space mission, the Dragon 9 SpaceX